Hello everyone, can you hear me? Hi, Sandeep Giri here. Are you able to hear me? Hi, Abhishek. Hi, Arvind. All right. Hi, Subbareddy. Hi, Savita. All right. Okay. So, Arvind, regarding Eclipse, we'll have a offline discussion, right? I saw your email. All right. All right. So the recording has been started, and just give me one more second. All right. So I think the questions are going to be a little problem. Oh, it doesn't show the questions that are. Never mind. I think Google Chrome will be a better option. All right. So today we are going to discuss start our discussion on pig and pig Latin. Okay. So we will talk about what exactly is pig Latin, what's the use case, and what is the benefits over the usual MapReduce. Okay. All right. So before we move forward, do you have any questions for me? The problem number two, you mean the auto completion one, where we were giving suggestions? Um, so we have already discussed that problem. So I'm looking for your solution. Yeah, Carl, I got your email. I have not responded because weekends are a little more hectic. So yeah, so I'll respond to your email. I've gone through your questions and okay. So do you have any questions related to the problem number two? I thought everything is clear, Anuj. All right, great. So that is something you have to submit and submit in your own way, howsoever suits you. You can create a GitHub repository. GitHub will give you a more visibility. Just that, please mention in the description a link to our website. No big data. That's all. Okay. So deadline for the assignment is that actually before we finish the course, I mean, before submission of the project, you should submit all the assignments. That is the deadline. And it's better to finish these problems before the next Saturday and Sunday. Okay. That way, your questions will be you will immediately get a feedback as well as you will also get suggestions. But if you are submitting after the project ends, we will you may not get the full feedback and you may not get time to fix the problems. Okay, you may not get time to fix the problems related to your problems. So it is better to finish all the MapReduce and Piglet in assignment by next week. Okay, so that is the deadline, because if you try to submit it at later point, we will consider it, but the problem with that is you may not get a feedback and we may not be able to help you out if you are really stuck. All right. Any follow-up questions of our discussion on MapReduce? No questions? All right. Then we will move forward. If you have any questions, feel free to write to us at Hadoop at No Big Data. All right. Okay, so what exactly is Pig? Pig is an engine for executing the data flows in parallel on Hadoop. On top of Hadoop. Also, please note that Pig also runs on the newer platforms like Apache Spark. We will discuss that part. So Pig is an engine for executing data flows on Hadoop. Okay, so Pig is the executor. Pig Latin is the language which Pig runs. Okay, Pig Latin is the language which is run by Pig, and it provides you the beautiful kind of operators, the operators we all are used to, such as join, order by, filter, and others. Okay, it runs on Hadoop and it makes use of both HDFS as well as MapReduce. All right. Okay, so just it is not supposed to be understood. Okay, the only reason I'm posting it here is to show you how does a pig Latin look like, so that we all have an expectation as to what to expect from this session. So, for example, the lines starting with double dash are comments, and the lines which are not starting with double dash is pig Latin. And if you look at it, we are saying input equals to load big.txt as line. We are loading this file from HDFS into input, and we are specifying that it is going to have a single column. And note that we have not specified any data type for this column, which we are naming it as line. Okay, and afterwards, we are iterating over the input. For each input, generate something. And what is that something? We are first breaking down each line into an array and then flatten it such that one row or one record contains only one word. So this words is nothing but a big table. You can think of it like a big table containing a word and containing a word in a record. All right. Afterwards, we are grouping the words by a column called word. And after we have grouped it, then we are applying the aggregation on each group. Okay, by doing a for each on the group. Once we are done with that, we are dumping it, means we are printing on the screen. So this was like one of the most awkward way of explaining a new language, as in we show you the language before you even know about it. But that's how it is. This is like a very big hello world in case of pig Latin. So this is how you generally learn a language. You look at the code, then you go back to actually basics, then you look at the code, then you go back to various syntax, and then and you generally do a really high amount of back and forth. If you have a look at Kernighan and Ritchie, for example, where they start with the code and then they start describing things so that everything is in a perspective. Okay. Okay. Krupa is saying what exactly is flattening means. Flattening is opposite of grouping. Okay. So flatten basically converts an multiple values in a record into one record at a time. Okay, we will talk about it as we go forward. So you keep this question with you. Just understand right now, this whole syntax is converting the line. So in case of input contains in each record a single line. Okay, you can imagine that there is this input is like a big table containing only one column and lot of rows, and this column contains text. Okay, a line, full line. And this flatten is basically flatten and tokenize is breaking this into into one word per record. All right, as we go forward you will understand it. All you understand is this is pig Latin. This is more or less like your SQL, just that it has got single statement at a time. So you will also notice few things here. At every step, each statement, such as input equals to load, words equal to for each, group grpd equals to group, and counted equal to for each. So all of these statement except for dump, every statement is generating a data set. Every statement results in the generation of some new data set. Every step is like a transformation. All right. Okay, so Anu's question is pig is one of the alternatives to MapReduce. So pig is more or less an alternative to an SQL. So when you churn the data in a traditional sense, you load the data into tables and then you churn it. But pig lets you do it in a little bit more simpler manner than SQL. Okay. So and the reason being the way pig behaves is you take the data, you break it down, you basically load it. Even if it's not structured, still you can process it. You will see it as we go forward. All right. All right. Now, pig is basically a data flow language. As we saw that data started flowing from pig.txt, it went to input and then for further and then further. So it's basically a data flow language. It helps us describing how does data flow, how it should be read, how it should be read, and how it should be processed, how it should be stored to multiple outputs in parallel. Okay. Now, the complex workflows, okay, so it allows you to describe complex workflows, as in multiple inputs you can combine together, then you can further split one data set into another, but it does not have things like for loop, while loop, and ifs. Okay, so that is the difference. That is the difference between Pig Latin and the other programming languages. So you can think of is our usual SQL, the way our usual SQL does not have a for loop, while loop, and do while loop in the core. Similarly, Pig Latin also does not have those kind of syntax. So the whole story of Pig Latin starts with data and ends with data. All right. Now, you might argue that what's the point of learning Pig Latin when we can do everything using MapReduce? The simple answer is, very simple answer is that MapReduce itself is very hard to basically program. Even an expert programmers find it difficult to actually get their work done on MapReduce. Say for example, if you remember our strange democracy problem, even a simple join was a very tricky thing. Therefore, therefore there was a requirement of having an easier way to do things. Also, if you start doing joins, for example, like the way we had democracy example, if you encounter multiple such kind of things, you will soon realize that you are basically repeating yourself all the time. You are again and again doing the same thing. Therefore, most of these tasks could be made very simple by inventing a Pig Latin kind of a language. So Praveen's question is, can Pig Latin be used in NoSQL DB? So can Pig Latin be used in NoSQL DB without using Hadoop? So some of the systems do allow have I mean Piglatin has been ported to some other systems such as Spark, but I'm not sure which NoSQLs allow Piglatin. Okay, though Piglatin allows you to churn data at HBase level, okay, HBase, HDFS, as well as Apache Spark, so it can churn data on any of them. But I'm not sure if other NoSQLs have started supporting Pig. But it is one of their core philosophies to basically support all uh, all kind of databases and platforms. All right. So here is the comparison. So Piglatin provides you join, filter, group by, order by, and union kind of syntax, which is something very easier to use as compared to what we did in MapReduce. Okay, the joins are really hard to do, and there is always a scope of making mistake. Also, Piglatin comes with internal optimizations such as automatically deciding how many reducers are required, but same thing is little difficult and need to be implemented in your MapReduce. Next is Piglatin understands your script the way SQL understands and can quickly check whether your SQL is correct or not. In the similar way, Piglatin can also be checked quickly and optimized. In case of MapReduce or in case of your Java code or any binary code, the code is fairly opaque to the system and there is hardly any scope of optimizing your code. All right, because MapReduce is fairly low level game. In case of Big Latin, there is a smaller code. In Big Latin, the same code which we have written in multiple lines, 100, maybe 60, 70 lines in MapReduce, same code could be written in couple of lines, and therefore it is easier to maintain, easier to develop, and easier to debug. I mean, easier to basically easier to maintain, deploy, and develop. Okay. So that's the benefit of Pig Latin over MapReduce on Hadoop. The only downside of Pig Latin is there are few things that you cannot do in Pig Latin. If you have a special requirement which has to use some functions which are not available in Pig Latin, then you would have to either use user defined functions or or you will have to write your own MapReduce. All right. So next question from Arvind is, can Pig Latin solve all MapReduce implementation? Very good question. The answer is no. It doesn't solve all the MapReduce implementation problems. Okay. Next comparison of Pig Latin with SQL is, so Pig Latin is good, is better than SQL because Pig Latin has been designed. So there are some frameworks such as Hive which let you churn the data using SQL. Now you might ask me that then what's the point of having Pig when you have Hive? First and foremost answer is that Pig can handle unstructured or semi-structured data, while for Hive you have to define the tables upfront. Second is Second reasoning is that in case, I mean, since SQL has been designed for relational databases, not really for Hadoop, but it has been designed for relational databases. Therefore, the kind of optimizations which have been designed in Pig Latin suit very well the distributed nature of our applications. Okay, so first reason was Pig can handle unstructured data. Second reason is that Pig is little bit more optimized and more controllable than SQL. All right. Also, with respect to the construct, in case of SQL, you demand things, meaning I want these two tables. Here you build things, as in you tell that this is how the result has to be arrived at. Okay, you will see it as we go forward. You will understand the difference between this. In case of Pig Latin, there is a long series of data operation, as in take this data, convert it into this, then take this result, again apply the where clause, then take the next data set, then apply these parts, and all that. Okay, while in case of SQL we just say that give me 5 records from this table. Here you generally say things like pick this, load this table, go and then filter this result, and then give me five records. So in case of Pig Latin might look a little bit more expanded, but in essence it's far more crisp, clear, and easily manageable than SQL. You yourself will see that even if you have been using SQL for quite some time, you would realize that if given a task, you would prefer to work in Pig Latin than Hive. All right. So parallel processing and distributed processing is what has been the aim behind writing the Pig Latin. While SQL is mostly the Hive has been developed, Hive SQL has been developed so that people who do not know anything about big data can still work on big data. Okay. Or if people have already a lot of SQL code, they can use that same code, or they can port the same code onto Hive. Okay. Yes, Pig can handle unstructured data in the sense that the way we had just loaded the whole line and then we split it into column and did the operation, right? And we did not define the data type of line. We just said that it's a full line, right? So in a way, Pig can help you do the ETL as well. All right, Sisha, did it make sense to you? All right. The use cases of Pig are many. As I just told you, first one is ETL. Why? Because Pig can handle the unstructured data, meaning you do not have to define the full table. Okay, you do not have to define the full table. And when you're defining the full, even the table, the various number of columns can vary across the records. So it's okay with Pig to have records, different records have different fields as in columns. All right. So it's great for using it on the to research on the data, and it also helps us do the iterative processing or batch processing. Okay, so we have a question from Shisha. Srisha says that what is ETL? ETL is a usual process of extracting, transforming, and loading data into the system. Okay. Extracting, transforming, and loading the data into a system. And this is generally used when you are parsing the data. You have the raw data from in one format, and you want to convert that into another format. In those cases, we use pig Latin. All right, this is a core philosophy with which pig guys have stick with. First one is pig eats anything, as in whether your data is relational, nested, or unstructured, pig can handle all of that. Second, pig lives anywhere. Pig basically it's basically not only made for Hadoop, but for any environment which is for parallel processing or distributed computing. It's not only for Hadoop. Pigs are domestic animals. Alright? Pigs are domestic animals, as in pigs are controllable and provide custom functions in Java and Python. Alright? When we say pigs are domestic animal, it essentially means pig are controllable animal. And and I mean controllable means that it gives you various functions in various language bindings so that even if you don't know a particular language, you can use the other language. All right, or in another words, if there is some function which is not available in pig Latin, you can write your own either in Java or in Python, and you can call that function from inside of your pig Latin. So that is called user defined function. Also, if your database is not supported with pig Latin so far, you can write your custom load and store methods so that pig can load the data from your database. Okay, and these load methods are very very simple. Okay, you are given an input. First you have to convert that input into record, and then you have to convert the record into the various fields. That's all. So Srisha's question is, can we use pig on our DBMS DBs? I think yes. There must be some driver which would provide you the connector, the load method for loading the data from RDBMS. So Abhishek is saying if user defined function from Python, Java can be included, then essentially every problem can be solved using pig. Yes, in a way. But for the argument's sake, the but we can say that those functions were not provided by pig Latin, therefore we had to write those in Java and so on. But yes, I completely agree with you. Most of the problems, almost all of the problems could be solved using using MapReduce, using pig Latin instead of MapReduce. And when you are using pig Latin and there is some function which is not available, you can write your own. As well as if a data format is not something which pig understands, you can create your own data load methods and data store methods. Okay, so Abhishek, all right. So we have, I think there are drivers for pig with which you can load the data from via JDBC. Okay, there are some drivers. I need to just have a look at it. It's just that I never needed to do so. All right, good. The last point, which is pigs fly. So pig eats anything, pig lives anywhere, pigs are domestic animals, and pigs fly. That means pig has been designed for performance. Okay. Do we have to worry about connection pooling etc in pig Latin, or framework handles? The framework itself handles when to open the connection and close the connection. Okay. All right. So installing pig is very straightforward in the sense that it's just a client, it's just a command which internally calls Hadoop with the MapReduce functions. So pig is just a command line, and pig provides you an interactive prompt also, where you can type immediately and see the results. So installing pig client is very straightforward. Download it from pig's release pages and then extract it, then move it to the correct location in your disk, or just link it. And then once you have linked or moved it to the right place, you can export a variable for describing where is your Java. Once you have exported, even though you have not specified where is your Hadoop, you can simply say pig minus x local. In this mode, it runs in a emulator mode, meaning it does not talk to Hadoop for doing things. It is just running in a pseudo mode. This will confirm you that pig has been installed successfully. There is no library missing, and it's running perfectly fine. And once you are done with that, you can specify where exactly are your config files for Hadoop line by mentioning the pig underscore class path as the environment variable. Okay, so environment variables is something which you can set when you open a shell, and it's available to all the shell environments. Or any program you execute, this environment variable will be available to you. Alright, so pig class path will help pig find the Hadoop, and hence it will know where is the name node, where is the data node, and everything. Next is, you may choose to add pig's bin folder into path so that you always don't have to give the absolute location, and then run the pig and enjoy the grunts. So what is grunt? Grunt is essentially a name of the command prompt. Alright, so but you don't have to install Piglet by yourself. We have already installed it on the cloud. All you have to do is log in there and run the command called pig. Okay. All you have to do is ssh student at Hadoop, say 2.nobigdata.com, or let's say Hadoop 1, or we can also log in on student at Hadoop 2.nobigdata.com. All right. Now we are logged in into Hadoop 1. We can simply say pig and it will start. Now you can see that it has discovered that where is our name node and where is the data node. Okay, where is basically it has connected to the Hadoop file system at the name node. Okay. Also, if you just want to run in a local mode, you can say pig minus x local. You can get out of the grunt by pressing Ctrl C or typing exit. You can say exit. No, you can just press Ctrl D. Ctrl D or Ctrl C, both will exit. Now, pig minus x local runs everything in a local mode, so it was not connecting to the Hadoop cluster. But this one, without any argument, when you run it, it will connect to the Hadoop and will give you the command prompt. From here, on this command prompt, you can run these file system commands. It's actually pretty easy way to talk to HDFS. So if you are running in pig mode, as in the normal Hadoop mode, every file that you refer will be referred as HDFS file, not the local file. But if you are running in local mode, as in pig minus x local, in those cases, the file will be located in the local file system. All right. So the data has been uploaded for today's session into this data folder in HDFS. You can simply say cd data. So every command you type in here is basically talking to the HDFS. All right. So this is like quickest way to see what's going on in HDFS. So these are the data sets available to us today. Okay. Sounds good to all of you? Any questions? Great. All right. So okay, so the local mode is only for testing and helps you do the development without the Hadoop installation. And it's pretty good way of quickly testing your pig script. And once you are done with that, you can launch the pig on the cluster and then test everything. Okay, now there are various command line arguments. The first argument which we had talked was minus x local, that was to run pig in the local mode. The other argument is if you say script, I mean, if you don't specify any minus x, you just simply write the name of one file. It will consider that to be a pig script. That means you will not have an interactive prompt. Instead, whatever is written in that script will be executed. And what is this script? What is a pig script? Pig script is basically a sequence of pig Latin statements. Whatever you type on this command prompt is a basic pig Latin statement. In case you don't want to keep on running it through the interactive command prompt, you can store it like a script, meaning sequence of commands, into a file and run it using pig and your script name. Okay. Also, if you just want to execute a single command and you don't want any prompt, you can simply say pig minus e and give the command name. If you are trying to say load this file, do this, do that, you can do that using pig minus e switch. All right. So the prompt is grunt. This is where all the commands are typed. You can also control Hadoop from here. Okay. You can also control Hadoop from here. Fs minus ls or cat or any of the other Hadoop command. Then you can run the kill job, exec, or you can run the pig script from here. Okay. So if there is a already running command, you can kill from here. You remember there was Hadoop kill command also, is the same as that one. All right. So the basic construction of a pig Latin script is that each processing step results in a new data set. When we are loading a file, that results in a new data set. A new data set is nothing but a collection of records. Okay, we also call it a relation. We also call a set as a relation. Why? As per the tuple algebra, each table is also called a relation. In databases, a table is also referred to as a relation. And each record in a table or each row in a database table is referred to as tuple. Okay, so that's the general tuple algebra thing. And all the UDF functions are case sensitive. Rest of pig is not case sensitive. And where you have to put command line, I mean the comments in between the commands, you can do a slash star and put whatever comment you want, and then you end it with a star slash, just like your C program, C++ program, or Java program, or any other program. So generally starting with slash star and ending with the star slash. Also, if you have only single line commands, you can just prefix each of the lines with double dash, just like SQL, and that line will get commented. All right. Okay, so this is probably my most simple script where I'm loading this data and then and then reaching to the average value of each ticker, each symbol's average value. So if you look at this data, I'll show you this data. What are we trying to do? So again, as I was telling you that I'm going to go a little back and forth. So be aware of that part. Okay. At any moment of time, if you feel out of place, just let me know. And okay, not this. We had data folder, right? Yeah. So we have data folder, and inside this there is this file called NYSE dividends. You can see that there is this big file. You can think of it as a big file. Okay. Now in this file you have the first column as symbol name, then stock exchange name. So sorry, this is the stock exchange name, New York Stock Exchange. This is the symbol name. This is the date, and this is the value of the stock. Now, what we want is for each stock, all we want is for each of these symbols, I want their average value. All right, not a big deal, right? So you can simply do things like load the data, this step, then check whether the something has been loaded or not. So this is a quick demo. I like to do a quick demo. So if we go here and we say divs equals to load this. Okay. Now quickly to check whether something has been loaded, we can simply say dump divs. All right. So it is basically launching the Hadoop uh, processes, Hadoop MapReduce. If you see here it says that timeline service is this, connecting to this, and then it gives you the URL to track. You can see that. Okay, so this is what is happening at the server level. All right. Now, when we are running a big Latin script, all I did was I loaded the data, I printed the data, and this is how it looks after printing. Okay. Next is we can also check when we loaded this data into divs, how does this divs look like? Divs is just a variable name. We have just kept the variable name. So this is how it looks like. So when you are optimizing, you might have to do the explain just like a good DBI. And then we did a group by a particular column. So we load here, if you see that this divs contains these four columns: name, ticker, and so we can also say describe divs. All right, it shows you that divs has got name, ticker, date, and the value, right? And the value. All right. Okay. And then we compute the average after grouping, and then we store the results. And it says that the folder already exists. So let's just create it, 11 July. Okay, so it has started the processing. And we can also have, once that finishes, we can say cat this file and see what is going on. So what we have done is we have said data out, and under that we have said okay, so we are saying here we can sort it by date and see what's going on. Yeah, this is the one. So this is what it has been generated so far. You can see that we have generated the average value of each symbol. Okay, using first grouping, then computing average, and then storing. All right, so I think it has finished. Good. So it has written to the disk. So also please note that exactly the way MapReduce work, you can see part minus R000 and so on. All right, great, Michael. So you understood how to load the data. All right, all right, good. So this was another example, sort of a teaser. And do not panic. All right, now going back to the traditional way of learning a language, you first define what are the various data types. So as a thumb rule, whatever data types are defined by Java, Pig defines those data types such as int, long, float, double, char array, byte array. Char array means string, byte array means binary array. Okay, when Pig does not know what's the data type of anything, it marks it as byte array. All right. Now those were the basic data types, and this is something new to all of us. There could be a complex data type. One of the complex data types is a kind of hash table or kind of a key value pair collection, and that is called a map. So the basic the apart from the basic data types, we can have data types like map, meaning a field in our input can be defined, or field in our data set can be defined as a map. Okay, it can be defined like a map. And what is a map? Map is a key and the value. In this map, the key has to be a string. Key has to be a string, meaning a char array, and the value has to be a value can be either basic data type or a complex data type, which means value of a key in a map could be another map. All right. Therefore, map is quite a useful function, quite a useful data structure or data type to store various kinds of unstructured, semi-structured, or a complex data. Now, other than a map, we have something called tuple. Tuple is just like our row in a database table. So our row can have further row, and meaning a tuple can have a further another tuple inside it. Okay, so tuple is the quality of a tuple, just like a database table's row is that you can, it's basically is a fixed length ordered collection of values. Fixed length as in it will have only those many columns. Okay, and it's ordered, meaning just like in a row, column 1 comes before column 2, and so on. So a tuple is like a database tables row. Okay, and tuple is made up of fields and their values. Okay, just like in a table we have column name as the fields and their values are there, similarly tuple also contains the field and their values. Okay, and if you have not given the names to columns in a tuple, then you can refer them with like an array, like using index of 0, 1, 2, 3, and so on. You can access them using position based operators. Okay, by using 0, get me the 0th value of this tuple and first value of that tuple. Okay, so also, is everybody with me or have I lost you? So whenever we can say, while defining our column or fields, we can say that this particular field is going to be a map. Okay, and when we load the data has to be in this format. Data has to be in this format. All right. And this is an example of a tuple. The first value of a tuple is a string, second is a integer, third is a float, and fourth is a map. You can see that it's a map, and this map has got two key value pairs, and first key value pair is name Bob and second key value pair is age hash 55. All right. So a bag, then there is another data type called bag. Bag is basically an unordered collection of tuples, which means you can put lot of tuples in a bag, and bag, if you look at it, it's basically like a database table. The way a database table has rows, similarly a bag has tuples. Okay, the only thing which we need to understand is when we are defining things, something like a bag, we should, I mean, this particular data set will be partially in the memory and partially into the disk, which means if we have humongous data which we are dealing with, okay, then we can use the bag. So Anuj's question is, so tuple is only for structured data? Not necessarily. Sometimes it could be the semi-structured data, meaning we know that there are fields in the input, but we don't know their data types. So by default, it will think of all of the fields. If you have not defined the data types, then it will think of all the fields inside the tuple as a byte array. Therefore, Therefore, it can also be used in the semi-structured data case. Now, Praveen's question is, when we are defining a map, do the keys need to be unique? Yes, that's a very good point. Thank you, Praveen. All right. Now let's go back to the previous example. what Anuj is referring to. So if you can see here, when we are defining our divs, it's basically saying that this will have four columns, but we are not telling the data type of these four columns, which means this divs is sort of an semi-structured data. Make sense to you, Anuj now? So here if you see, we did not define the data type of name, ticker or anything. It has been inferred. It has been inferred by the pig. Alright? Alright, Anuj? Okay, so your last question is the tuple of number of fields. So generally, if you do not know the number of fields in the input, you create a tuple with a single field, and then you can fix it. You can basically parse it and create another data set. All right. So that's what we did in case of word count example actually. Okay, now we have Savita's question. What is the type of variable length for variable length string? Okay, so the data type for variable length string is char array. Okay, it's a char array. All right, good question. Thank you, Hariharan. By default, the usual behavior is when we are loading data like here. Here we say load blah blah blah, and these are the columns. So Harian's question is, how did pig, what is it that pig inferred inferred the separator? Okay, so by default, this load command tries to split the record into values which are separated by tab. Okay, so in case you have here some other data type, then you will have to specify here while loading that my input need to be split based on a certain character. Say maybe your file is comma separated, then in those case you will have to say using pig catalog and then comma. I'll show you that. Now, what does dump divs do again? Okay, that was Michael's question. So dump div basically prints whatever is there in the divs. Load loads the data into divs. Dump prints everything onto the screen. Explain or describe shows on the screen what's going on, and so on. Okay, you will see it as we go forward. So these are the data types which we are dealing with. Okay, so here the group by, unlike the SQL command, the group by and the aggregation are part of two separate statements. Here we are saying group divs by first column, which is second column, which is ticker, and then we are saying go through each of these groups. Okay, go through each of the groups, and for values compute the average. We are calling an average function from the library of our pig. Can we debug these commands? The only best way to debug these commands is using explain keyword, and that is probably the best way to debug it. Okay. So Krupal's question is, could you explain the bag again? Bag is like your database table. Bag contains tuples the way database table contains rows, right? Therefore, tuple is like a row in the database table and a bag is like a database table. Okay, bag is like a database table and tuple is like a row in the database table. So I hope that clears what is a bag. Correct. Thank you, Santosh, to making it clear. So his point is, so does it mean group by does not sum up similar items like what SQL does? It just brings rows together. That's exactly what it does. It basically brings rows together but does not operate on it. Okay, so that's a general philosophy of pig, that the whole complex query is broken down into steps, and that makes the life really easier. So all tuples should be of same type. Um, Even if there is one data type which is not of same type, still pig will not complain about it. Okay. Sometimes when you start doing processing, only then it will complain that, okay, this data is not fitting into my tuple definition, therefore there is some error, please fix it. Okay, does it make sense, Shisha, Sirisha? Great, great, very good questions. Any other question? No. All right, so we were talking about data types. Also, please note that pig is not very specific about schemas. You can either tell upfront, for example, dividend equals to load this and that. Okay, so you can say that load NYSE dividend, and this is my column definition. It has got four columns. First is exchange, which is a string symbol. Second is symbol, which is a char array. Third is a date, which is char array. And fourth is dividend, which is float. Okay, okay. Any other questions? Alright, so Pig is not very particular about schemas. You can either define the data types of each of the fields, or it will make the best guess. Second is, when you are when you are defining the definition for the complex data type, you could also define things like, you can say load NYSE data as either put only A in this whole bracket, or okay, let me just try to show you how, what, in what all ways you could define. All right, let me just try to do it here. That'll be easier for all of us. Can you, is it visible to you? So either we could define this, or we could say things like this, or this, or maybe, or maybe, maybe just one field Okay, like this. Or maybe we can just define one of the fields. Either of the fields is totally optional. Like here we have only defined dividends data types. Or also we could define things like, we could also say nothing about anything. Okay, we could only say first column. Okay, in that case the rest of the columns will be addressed by 0, 1, 2, 3 and so on, while the first column could be accessed using exchange and 0 index. Okay, or you could also say things in a more simplified manner by saying nothing about the column names. Okay, so Praveen's question is, Pig Latin will always be like Linux commands not supported by Eclipse? No, there are plugins in Eclipse which support Pig Latin. So Anu's question is, does Pig Latin take care of multiple spaces or tabs between the data? It does. So basically multiple spaces are not considered as tab separated. Only the tabs are considered as the tab. Okay. If you have multiple spaces or tab, you can utilize regular expression based loader, which where you can specify that separator is my regular expression. All right, Anuj. All right. So this is how you can define. It will basically load the data. So Girish's question is, when we are not giving any of the column names, how will it load the data? So it will basically load the data, just that those columns will not have names. It will automatically create the columns based on the input fields, based on the separator, which is by default tab. And in that case, it will not have names for those columns. You can access those columns as 0 and 1 and 2 and 3. All right. So, okay. Okay. Now, Anu's question is, let me explain a little bit more. He could not get it, and maybe I could not explain it properly. Now, does pig load takes care of multiple spaces or tabs between the data? So the pig load by default only considered tabs, not spaces when loading the data. So multiple spaces are not equal to tabs. All right. In case your input data has multiple spaces and you are not sure about whether it would be whether my fields would be separated by spaces or tabs, it could be either. In those cases, while loading the data, you can say that my loader is a regular expression based. Okay, which means we can say that we can write things like, while instead of saying that my separator is something like space, we could say space tab or any number of those as the separator, but you will have to use regular expression based loader. All right. Yes, so I'm talking about customizing the delimiter, which is by default the tab. All right, good, very good questions, keep them coming. Okay, now the way we were defining char array byte array, in the similar manner we could also say a is my map. Okay, and inside map, as I was telling you, there could be a key which can be only of string type, but the value can be of different data type. So you can also, while saying that my A is map, you can also go a step further and say that the value is of type tuple. In this map, the value is not a string, it's a complex data type of tuple, and inside tuple, what are the various columns that also we can define. Similarly, while defining a column that, hey, my input column, my field is a tuple, you can either say simply the tuple, or you can just leave a without any marking, or you could say a colon tuple and define the name of the various fields inside the tuple. And you can go one step further and define the data types of each fields. So all of these definitions are valid. All right. Similar is the case with bag. In case of a bag, since bag only contains tuples, so you can further go a step further and say that my bag contains tuple which contain these fields. All right. So in case you are getting an error, it says that you cannot run average on string values, you can put the data type, like you can put float in the brackets and say that I'm trying to cast the values. Then pig will try to cast the values into float or any other data types which you want. Just like in Java, C, or other languages, you could cast one variable's data type into another using brackets. Here also you can do the same thing. So Anuj's question is, can we have a tuple inside a tuple? Yes, why not? Okay, you could have things like this, okay, and where let's say Z is further a tuple, and you could again define the column names inside the tuple. I will show you Kirupa after a bit of time. So Kripa's question is, can you show us how to define a regular expression based loader? Okay, so there is a custom UDF for loading using regular expression. All right. All right, let me go forward. So we will also see how we can load it using regular expressions, right? And we also see how can we load a JSON object into our pig data, into our pig data sets. All right, so the first statement with respect to pig is load. We say divs equals to load and specify the data set. Then we can go further and say that load my data. By default, whenever you are saying load, it's considering it will basically try to guess the data type of fields, and tab is considered as the default separator. And you could either say NYSE dividends. In this case, it will expect that NYSE dividend would be stored in HDFS in your home folder. Okay. In case you do not have, you don't want to give a relative path, you can specify an absolute path saying slash user slash student slash data slash. So here it is basically, right now it would be data slash this. Okay, so either you could specify the relative or absolute URL. Then in case your input is not formatted by, is not separated by tab, you could use pig storage with comma as a separator. If your input data is comma separated values, then you could use pig storage and comma. If you have a CSV to import, so this will basically create a dataset called divs. After loading the data from NYSE dividend, one line will become one record and data in that line will be splitted by comma. Okay, and thus we will have the fields which are comma separated. Now sometimes you have multiple files to load from the same folder. You can specify asterisk or star as the wildcard. If you have 100 files starting with nyse underscore div, you could simply say nyse underscore div asterisk. That means all the files starting with this particular name will be loaded because of the wildcard. Next is, let's say you want to process some data from HBase. If you want to process some data from HBase, you could say things like load this particular table. Now, when you're loading something from HBase is like a database. So there you are saying that load this table from HBase storage. Okay. Next is that you could also define the data type upfront, or you could define it later point of time. Next is that in case you want to load a JSON object, you could use JSON loader. Okay, so you could say load this particular JSON file using JSON loader, and here inside the brackets you could define the data format inside the single quotes, the data format of JSON, which is the input. Okay, so it will expect one particular element in the JSON as food, other is person, other is amount. Okay. Yes, we can have regular expression in the pig storage. No, not here. Pig storage does not accept the regular expression, but there is a different storage which we can load. I think it is called regex pig storage. Okay, I'll have a look at it. It's a UDF basically. It's a third party. It doesn't come inbuilt with pig. Okay, so Anu's question is very good question. If this divs is in the memory, then it's a huge data to load into the memory. How will it work with big data? So a very simple answer is divs is not the data. It's just the representation of the data. Okay, so although the language make it look like the moment we say load, the data got loaded and data got loaded into this particular variable called divs, which means whatever is your data size, that much memory will be consumed by divs. No, divs is just a pointer to the actual data. Divs represents your pig Latin statements, right? Any data set in case of pig represent your pig Latin statement which has been used to data generate that data set. Okay, so this does not really load the data into the memory. It just makes a note of it that this user has tried to load this data, and whenever you say dump or store, the actual process of doing things start. Okay, actual map reduce will get started. So main data game is being played inside MapReduce that will get launched only if you say store or dump. So when you say load this, load that, and even if you say 1,000 times, you load thousands of data sets, it would make no difference to the memory. So make sense to you, Anuj? Is it like indexing the record? Not really. It's not even indexing. It's just making a note of it. The divs represents this particular command. Divs represents this particular command. So when you will try to access the divs, only then these commands will get executed and actual work will start. All right. All right. So Kirupa's question I have noted is asking if we can give a demo with respect to the, let me just make a note of it. Okay, and let me try to show you, because for using regular expression as a separator we would require a UDF for regex. All right. So what was that, Anuj, what was the question so that I missed? So Anu's question is, so the pig commands directly applies to data node having the files? Not really, not really. So if you are saying cat, or if you are saying ls or something, they will all go through the name node and will give you the result. Okay. So internally, pig is not violating anything. It is just doing the way. If you had to do the same thing using MapReduce, what are the things you will do? You will create your mapper, you will create reducer, and you will provide the one particular file as the input to your mapper reducer. Exactly in the same way, pig will be doing, pig will be executing. Just like you could have converted the same requirement into MapReduce, pig also converts into MapReduce every command you pass it on to. Okay? Alright. So let's take a 10 minutes break and then we will take it forward. Okay? All right, I'm back. Are you able to hear me? Should we start? All right, great. So, any questions before we start? Abhishek says, for table from HBase, it will load the field names automatically. Yes. All right. All right. Hi, Damodaran. Okay, I think you're a little late, but don't worry. I think you'll be able to catch up. Yes, in HBase also there are the field names and the field values. It will automatically load those directly. All right. Now going back to the our discussion. So if you're writing a lot of big Latin, you may want to use a highlighter or and there are many highlighting tools. Also for diagnostic and understanding what's going on, you could always say explain my dataset or describe my dataset. All right. So that is one way to know what's going inside. Next is so we talked about so far when we are running a big query, the first statement we use is load. Load loads the data, but not now, but where it basically hints, it basically tells Pig that we intend to load this data. Okay, and this is going to be their data type. Similarly, we have store and dump. Store stores the file into HDFS if it's running in a proper Hadoop mode. If in case it's running in local mode, then store will store it in the local file system. Similar to load, we can also say by default it will store as tab separated values. In case you want the values to be separated by comma, you can say store my dataset into my HDFS file using pig storage and then comma. Okay, so this is how the store works. This is how the store works. So sometimes you just want to see what's inside the data set. If you want to see that what is the data that is there inside a data set, so you can simply say dump, and it basically will act like a print. It will print everything onto your screen. Okay, it's generally not a great idea, but for testing purposes running in the demo mode when you are only churning few hundred records, dump is okay. But do not try to run dump in the real mode because there'll be millions of records and that will do the screen blindness for you, meaning lot of text will scroll through your terminal and it'll take a lot of time. All right, this is only good for debugging. All right. So first syntax was load, other we talked about store and dump. Now the next statement which is very important is the for each. For each is called projection. Projection means we go through each and every record and then we do certain operations on the record. So for each goes like this. For each, my dataset name, generate generate ticker comma value. And while calling generate, and we are saying that give me only two columns out of this whole data set instead of all four columns. Okay. So we could also say things like square root sqrt of say value, not ticker but value. Okay, we could also say things like square root of the value. So we could run the mathematical operation on top of any of these variables. And that is the role of for each. Are- all right? All right. Next is, so this is the most basic form of our for each. I'll just try to run it. Or let me try to run on the second one. This is better because if multiple people run pig simultaneously, it takes a long time. So we say, and also please note the actual processing of the things will only start when you say dump. Okay? That means there'll be two times. Every time you say dump, the whole MapReduce process will start. Okay, we say div equals to load, and then we say dump. It'll start the whole MapReduce process of loading this file. All right, and when we say value equals to this, and then we say dump my values, then it will start from here, load the data, and then compute this. Okay, but in case of map, we will talk about this even more in more details. When we say dump values, it will execute this and this. Why? Because to know the values, we need to know divs, and to know the divs, we need to execute load, right? But we don't need this statement. So when you say dump values, this will this will get executed, this will get executed. But when we say dump divs, only this part will get executed because divs only depend on load. So Arvind's question is, can we print first 100 rows in Pig Latin? Okay, so mm, there is a command called limit. You could use limit, and that will only give you the first n number of rows, just like SQL limit. All right. So using limit, you can also say instead of saying something like this, we could say divs, and let's say I call it 100 equals to limit divs 100. Okay. This way, if you say limit 100, it'll give you only the 100 records. All right. Dump values gave us this list, and then now we can say things like values equals to, and then we can say dump values. Okay, so when you say dump values, it will essentially keep only the two columns, that is ticker and the value. Ur's question is that with limit, will it read all the rows and then limit, or is it smart enough to only read the limited rows? Very good question, Urs. So when we were saying limit, right? When we were saying limit, so his question is, will it read all the data from the disk and then only print 100 records, or it is smart enough to just stop reading the file after first 100 records? Okay, so very good question. So it basically tries to limit only to first 100 records because IOs are heavy. So it will only read 100 records. It will not read the whole file. All right. Very good question. So I'll just take it out. All right. Okay. So next forms of for each are really interesting. Say, let's say you are trying to compute the difference of close and open bid of NYSE daily report. As in, what is the delta of close and open? If you are trying to do that, you can easily do that in for each, which is called projection. So we can compute and we can create a new column on a new value by saying for each prices generate close minus open. So gain will be having lot of values, lot of rows, and each row in this gain will have only one value, which will be the result of close minus open. Gain 2 equals to for each prices and generate $6 minus $3. Sometimes you don't have the name. As I was telling you that it's not essential to specify the name for columns. In those cases, you can simply access the columns by putting $6 and $3. Okay, so the same thing could be written as close minus open could be written as $6 minus $3. 0, 1, 2, 3, right? Open. 4, 5, 6, that is close. So $6 is close and $3 means open. All right. Sometimes you want to print a range of fields. Okay, you want to just pick and select only a range of fields. Say in those cases you can use dot dot. Okay, so you can say for each. So if you want to pick all the fields up to the column name open, you can say dot dot open. If you want to pick up the all the fields from open till close, you can say open dot dot close. If you just want to pick up the all the fields from volume till the end of the line, which means volume and ADJ close, in those case you can say that volume dot dot. Okay, so this is the other forms of for each. These are the other forms of for each. Now Arvind's question is, can we compare index price against stock price? Okay, that is NYSE value against uh, IBM stock price. Yes. So you can definitely do that using, as you are saying, that filter out outperforming stocks. So you can definitely do that. Okay. Let me again understand what I'm trying to hint at. And probably this will get clear as we go forward with our filter, join, and group by. Okay. Your question will automatically get answered, I'm hoping. In case it doesn't, then we can have a discussion again. All right. All right. So this was the very basic syntax. We talked about loading a file into Pig and then applying and then storing. Then we also talked about limit briefly. We also talked about for each, okay, and store, dump, all of that we have just talked about. Now, let's try to understand, as I was telling you, that underneath the skin, Pig is basically converting everything you do into MapReduce. Anything we have done so far gets converted into our MapReduce job and gets executed on the cluster as if you told me something in terms of Pig Latin and I wrote my Java code and get it executed. Now you'll have to do a little thinking through that if you had to do the same thing using MapReduce, what kind of maps and reduces will it be creating underneath? Okay, let's go through this a quick exercise. I think that will give you a clarity. So if we have a statement like gain equals to for each prices generate close minus open. So for each prices generate close minus open, do you think this statement will generate reducer side code? Okay, will it have any reducer side code? So what are we doing? We are going through record and operating upon this. Okay, if you had to do the same thing using MapReduce program, all you will do is go through line by line and parse each of the line and then compute close minus open and print that as a key and value as nothing, right? And that should give you the result. So do you think you would require anything on the reducer side, or do you want reducer phase at all? So why do we need reducer side, or why do we need sorting in the first place? Do we need sorting in this? Can we just turn off the sorting of Hadoop? We can actually turn off the sorting, as we discussed earlier, that if we are not specifying any reducer side code, we can easily turn off the sorting. Correct, correct. So we have correct answers from Srisha, Anuj, and Abhishek. It will not have any reducer side code. Okay, there will be no reducer side code generated. Yes, that's correct. Savita, we don't need, because her reasoning is correct, that that we don't need reducer since it will be taken care by the mapper itself. That's very correct. Great. Thank you, Arvind. Reducer will not be needed because compute will sufficient uh, for our result. Maybe you are saying map side computation will be sufficient. All right. Good. 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 Now, next question to you is oh, there's no question. Next question. We'll talk about more questions afterwards. All right. Now, same thing what we have done for a normal data type, we could do the for each on the complex data type as well. So we could load our input like this, and then we could iterate over the values. Okay, so if our input contains a tuple, say each record of this file input, we had two columns, x and y, and we only wanted x twice, okay, instead of three columns. So we could easily say for each a, generate generate t dot x and t dot dollar zero. Okay, this would only give us the first column twice. This will only give us the first column twice out of this tuple. Now, in case you have a bag, input contains each record as a bag of values, meaning multiple tuples in a single row. In those cases, you can say things like, give me only the second value of the bag. Okay, so it will give you all the second values of all the tuples in the bag. All right. Also, if you are selecting multiple fields of tuple, instead of saying b dot x comma b dot y, you could also say b dot x comma y. So this is equivalent to saying generate b dot x comma b dot y. Okay. Okay, so Anu's question is, why can't we say for each generate t dot x and t dot x? Okay, t dot x comma t dot x. We could say, I just wanted to demonstrate that you could say t dot dollar zero as well. Okay, it is just for demonstration purpose. All right. Any other question for me? Okay. Now, you could also do a complex computation such as saying for each divs generate dividend into 100, and you could give a column name to the computed one, or you could choose not to give a column name. Okay, just like SQL, just like saying select A into B as something. Similar way, we can also give the column name or we can avoid it completely. All right. Also here, so you can say load NYSE underscore dividends and as this particular row, and then we can apply all these functions. Also, a detailed list of function, you can go through this detailed list of function. It has all the functions that you think about. Okay, such as, okay, let me also see what are the text loaders available. All right, and you have all these mathematical functions, you have string functions. Say you want to, one more thing you can do actually when you are, I forgot to tell you earlier. So when you are loading something and you have to split it using a say regular expression. So a better thing would be to use this function called regex extract, or function called regex extract all. What it does is we'll say for each all my fields, and then we say that split that particular field, split this field by this argument, okay, by this regular expression. So it will basically split this using this as this as the regular expression. Okay. Make sense to you? And whatever portions you put brackets around, that will, whatever value is matching through this bracket will become your first column, and the second bracket will become the second column. Make sense to you? You were asking, right? Somebody was asking me. I forgot the name. I think Hariharan, Kirupa was asking, and I think Hariharan was also asking. All right. So you could use. I like this function very much. You could use it at a lot of places. So you could use the brackets. If you put the bracket, it'll create a column with the value that's matching with, which is inside regex. Okay, and this makes it a very fruitful function. All right. There are all sorts of functions which are available to you, such as datetime function. There are sometimes you have to convert one data type to another between bags. So let's say you have to convert this into some other format. You can use to map, to bag, these kind of functions. These are very useful functions. All right. Now, Carl's question is there implicit casting to float if we have type 100 instead of type 100.0? So it will basically try to cast a value into int if it doesn't have decimal number. Otherwise, it will try to cast it into float. Okay. So a wiser choice would be, in the case you have some doubt, you cast it by yourself. You convert the text into number by putting brackets in front of the, say, for each, and then you put the bracket, and then you say float, and then you put the column name. This will translate your column name into uh, cast the column value into the float value. Okay, did I make sense, Carl? Okay, thank you. All right, moving forward. Now comes the real important functions which complete the pick. All right, the first and foremost one is group by. Okay, group by means, so we talked about load, we talked about dump, we talked about store, we talked about limit, and we talked about for each. Now, group by. Group by is a function which forces pig to group a particular data set by a particular field. Let's say we are saying group A by F1. Okay, and what does A have? So what does A have? A basically has name and age and GPA. Okay, so this is what it looks like. Now when you group A by field 1, okay, let's say group A by age. Here we are saying group A by age. What happens is the newly generated data set will look like this. There will be first field with age. The name of that field will become the group, and all of the all of the records that are having 18 as age, they will be grouped into a single bag. Okay, this is a single bag containing all the records that have 18 as the age. So it basically formed a group, and group in the form of a bag, right? As we were saying that it wouldn't do anything, it wouldn't compute the values, it will just bring all those things together. That's what it has done. Okay, same case is with Mary, because for 19 there is no other. At 19 is there is only Mary, therefore there is only one tuple inside the bag. And same case is with the 20. All right. called. All right, good. So this is how the group by works. You can also group by on multiple columns. Okay, you can group by on multiple columns, not only one. And also note that the names of the newly generated columns. So inside this tuple, inside this collection, the tuple names are like this. Okay, name is GPA, whatever we had earlier here. Okay, just that a newly generated column has been one is added called group, and the second field name is A. This is A, and it'll look like this. Okay, let's just see if I have A. Okay, not really. Okay, if I have, we'll just see it when we have couple of examples. So is the group by clear? These, what are these column names? New column will be created with the name called group, and there'll be second column called A. A is same as the dataset name, and this A will have a value of type map, and this map will contain the tuples of these tuples with these fields. Alright, so group by is clear to everyone? What's happening in the group by? Great. Now there is another command called flatten. Flatten is just opposite of our group by. And what does it do? Say for example, Sandeep is first field, and second field we have is a bag containing C and C++ as two tuples. Similar is Arun having these values. And so if you have this kind of a data and you say flatten, if you say for each ax generate name comma flatten is nothing but a function. Okay, flatten the languages, it will generate Sandeep C++, Arun shell, Arun C money Java, C money C++, C money Lisp. Okay, so it's just opposite of group by. Okay, so somebody was asking what does flatten do? This is what the flatten do. All right. Now the filter part. So you can only keep some records. You can only keep some records while churning the data by applying filter. Let's say all we want is that only some records. We are saying div filter divs by symbol matches this. By as in here, after by you have to put a condition. There'll be operand and there'll be operator and there'll be and or and all kinds of logical operators would be there. So you can say filter divs by this condition. This condition is symbol matches cm dot star. Can anybody tell me what does it do? So cm dot star will match with what all? What does this regular expression mean? Okay, okay. I think Hariharan is right and Girish is also right. It gets the data for CM matching. No, not really. Yeah, you're partly correct, Girish. Partly correct. CM dot star. What does it mean? Correct, Kurupa. All the records starting with CM. Same is Carl. Anything that begins with CM. All right. Thank you, Damodran. Anything after CM, one character or more. No, this is not one character or more. Zero characters or more. Okay. Uh, Again, Anuj, same thing. Starting with CM and at least one character. Not really. Zero character because asterisk means zero or more. Correct, Srisha. Okay, Savita says it will match the pattern CM dot star. That's exactly my question. What does the CM dot star match? So Damodaran says, shouldn't it be uh, it be caret CM and then dot star? Yeah. Had we used search, in that case, we could have said uh, start matching, start finding from the beginning. But when we say match, match generally means it will start from the beginning only. Yes, Risha. Dot means any character and asterisk means zero or more of that character. All right. Sometimes you have to filter where the condition is not matching. There you can say by and put the not before the whole condition. Okay. So if you do not want symbols which are matching CM star, then you can say filter divs by not symbol matching CM dot star. Make sense to you? Now, in the same spirit, we could actually combine these operators, these all conditions together by using and or maybe sometimes not, not, not. Okay. So using these operators, we could combine very complex conditions and filter the records. Okay. Again, here you can see there are logical operators. These are called logical operators or Boolean operators. Yeah, here are the Boolean operators. So and or in and not. So you can say filter A by f1 equals 8 and this and that. Okay. So you can have a look at that. These are the various other operators. Okay, so have a look at the more operators at this URL. That will be quite helpful to you. So Arvind's question is, if we give CM star instead of CM dot star. Okay, so all right, I think Arvind, you have not watched my regular expression sessions. I would request you to watch the regular expression session. So I'll ask all of you, CM star will match which one? Okay, A is CMMM, B CM, C CMA, D CM, let's say C. So CM star will match which all A, B, C, D. You can select more than one also. Okay. Damodaran says A. Okay, I think I should give you little more time. So Anuj says A and B. Okay. Sirisa says A, B, and C. All right. Carl says A, B, and D. Okay. Savita says A, B, and C. Okay. So out of all, Srisha is correct and Carl is correct. Okay. So it's actually A, B, and D. Okay. So why? Why? Because asterisk means zero or more of the character that it is following. The zero or more of the preceding character. And what is preceding character? M. That means zero characters of M is C, one character of M is CM, and if you have CMM, CMMMM, whatever, so therefore it will match with A, B, and D. Okay, that's correct, Anuj. All right, so go through the regex video in the beginning, because if you notice that everything starting with the filter, loading this regex split, even at a lots and lots of places you will find that even our sed command or our grep command, everything uses regular expression. Therefore I urge you all to go through the first session's regular expression video. I'm hoping that it's good enough that you will like it. Okay. So Carl's question is it possible to use capture groups with big queries like this or this? Yes. So for those all cases, if you want to say filter on certain regular expressions, certain part, a better strategy would be to just transform the data set using the split functions like regular expression replace functions we talked about. Okay. So if you have a look at this one, okay, so you can use the capture function here and capture those fields, separate them out, and then you can match them. Is that what you're looking for, Carl? Okay, thank you, Srisha. Srisha found regular expressions very helpful, and she can now understand almost all regular expressions. I'm very happy with that testimony. Great. All right. So it takes a little bit of time to realize that half of the work of regular expression can be handled using regex extract all. So it's not that obvious in the beginning. Carl? All right. And now moving ahead. Now again, same question. Will there be any reducer side code generated with this statement? Start with cm equals to filter divs by symbol matches dot cm dot star. Will there be a reducer? Girish says no. Michael says yes. And Srisha says no, we don't need reducer for this. Okay, that's correct, Girish. It's only doing the reduce mapper side job. There is no reducer. We are not grouping anything. We are not sorting anything. Therefore, we do not need a reducer for this. All right. Thank you, Kripa. Thank you, Subbareddy. Okay. And Abhishek. Michael? So basically, when if you remember reducer side code, g- generally we need reducer side code when we are sorting the data. We can turn off all the reducer, as in where all the sorting will happen. We can also turn off that we don't require any sorting, right? Because it's not much required here. We all we need to do is whatever is the input, read it line by line, transform it into another way, and skip all the records where there is no condition matching, and that's it. All right. Did it make sense, Abhishek? No. And Michael? All right. Now keep that I mean, ready. All right. So next is order by. Order by basically orders your data set by a column or multiple columns. And optionally, you could also put descending or ascending keyword. By default, everything is sorted, or by default, everything is ordered by in an ascending manner. If you wanted descending, then you can put descending keyword, DESC keyword, next to the field. All right. Now there is another like unique command in Unix. There is a distinct command here which basically finds the distinct values of the values in the data set. For example, if we try to find out what are the distinct symbols, we can simply say distinct symbols. Let's try to do this. Let's try to run this. All right, it is going to take a bit of time, I think. It's doing something. So it will basically give us the distinct rows from that particular data set. Now you can see that. It gave us the distinct symbol names. All right. Now, now question to all of you is when we say will it generate any reducer side code for unique symbols and we say distinct symbols, will there be any reducer side code? For the command distinct, does it generate any reducer? Or to compute distinct, do we require sorting? So Arvind says that it's a built-in function of pig. No, actually it will generate the MapReduce code and that will get executed on Hadoop. It won't happen on the pig side as in memory. It'll happen, everything happens on the MapReduce side. Alright. So the it will actually generate it will have the reducer side code. Why? Because to do the distinct, you will have to have the key value pair, right? And if you remember, all the output of the keys is will be distinct, correct? The way we did the word count problem in the same fashion, Okay, so we would require Hadoop side sorting. It can't be done on the mapper part, Anuj. If you try to do it on the mapper part, it is going to be really, really difficult. No. So distinct is not done by the mapper, by the way. Correct. Mapper only churns the input from one form to another. Right? Okay, so pig also provides you the join command. Using join command, you can intersect two data sets or two tables you can join together. The easiest one is if you have, say, NYSE daily and another database called NYSE dividend, you can join daily and divs. And also please note that the syntax we are saying join daily by symbol and divs by symbol 1. So it will bring together all the records where daily.symbol is equal to divs.symbol 1. Okay, so it will basically bring all the records together where daily.symbol is equal to divs.symbol 1. Is that clear to everyone? Okay, so Anuj is correct. Okay, let me just talk quickly about what we are trying to do here. Just give me a second. The fan is making a lot of noise. I'm afraid that, like yesterday, it should not shut it down. Okay, so Anuj was saying that we need Hadoop grouping to get the distinct values. Okay, so Srisha, are you asking about a little bit more explanation of distinct, or why do we not require reducer? Okay, so I mean, if you think about computing distinct, what will be the best way to compute distinct using MapReduce? Okay, and if you remember in our word count example, we already did the distinct, but But on the reducer side, we were just counting words, and all the words were actually distinct. So in case of if we had to do the word count, if we had to just find the distinct values, what we will do is in the reducer side, we will basically skip all the values and only print the keys, and that will give us the distinct values. Okay. Correct. Thank you, Abhishek. Probably that's the best explanation. So Abhishek is saying that distinct cannot be done using the mapper because, like in the word count example, words will be on different chunks, which means it is not only on one machine, it is on multiple machines. Therefore, we cannot do it on the mapper side. All right, makes sense to all of you. All right. Also, in this in join, you could join two database tables, two big data sets. You could join two big data sets on multiple columns as well. For example, we could say join daily by exchange comma symbol and with divs on exchange comma symbol. So wherever exchange comma symbol of daily is matching with the divs, all those records will be brought together. Okay. Now There is a little bit of difference you should notice. One is the self join part. In case of a self join, you cannot simply say join daily by this column with daily. You will have to do a little bit more task. You will have to load a HDFS file twice, like div1 equals to load this, div2 equals to load this, and then you can join div1 and div2. So self join are not that straightforward in case of pig. Okay. Now there are few more things you should all note about joining. If you are coming from SQL background, you will find few differences. First is join should always have at least one column. Like the way we had in SQL, we could just join select star from A comma B without specifying any column or anything. We could do those kind of things. That is not possible in case of pig. If you do not specify a column on which we are trying to join, it will give an error. Second is join cannot have conditions. Okay, join cannot have conditions, as in select star from, for example, select star from A comma B, where A dot value is greater than B dot value. If you have to express the same SQL into a pig Latin statement, you will say join A comma B on A dot value greater than B dot value. All right. That is not possible. So this kind of join is not possible, and join should always have at least one column. And third difference was the self join part. You will have to be little cautious while doing the self join. Okay. So can anybody tell me, help me understand why are these restrictions? Why are these restriction? Why is it so different from normal SQL? Why do we need, in case of our in case of pig Latin, if we are trying to join two tables, why do we have to always provide at least one column? And why can't we join based on a condition? Anybody? Can anybody help me understand that? Anyone? Yeah. So, okay, nobody. The reason is the way, if you remember our fifth problem, the way we joined the two tables was making the field on which we are trying to join, making that particular field as the key for our mapper, so that all the values for that key will come together. And that's how we joined. Therefore, since we therefore we have to have at least one column on which we are joining. Otherwise, how will the mapper work? Because mapper has to have a key, right? That makes sense to you? Because the way join happens in these tables, the way underneath the pig Latin, what exactly is happening when I'm joining two database tables A and B? It will create the mapper will create a key on which we are trying to join these tables. Mapper will create that key and value will be each record. Okay, that's how the things are joined. Okay, so if you do not specify a column, it will give an error. It will say that you have to specify a column. Okay, so this is what happens when we join the two tables. This is the result. So if we have A and B, okay, So we have A data set and B data set. A has two columns, ID and name. B has ID and name, and we are joining A and B, A by ID and B by ID, and we are joining these two, and then we are dumping the result. So one Sandeep has coupled with one Giri because the ID is matching both the sides. Okay. So is this clear? This result? How is it working? Yeah. So this is a normal join. We are joining A and B on ID on both sides. A dot ID and B dot ID. Yeah, is that clear? So Damodaran's question is why 2 and 3 are not joined? Because A dot ID, which is 2, is not, there is no corresponding ID equals to 2. Alright, Damodaran? There is no corresponding. Joining means ID from both the sides will be matched together. If we are joining on ID, that means ID of B and ID of A will be joined, will be bring together. So 1 dot Sandeep comma 1 dot Giri. That's what is the result. Okay. Now just like any databases, we have outer joins in SQL. The first outer join we'll discuss is left outer join. And what does left outer join means? Left outer join means even if there is no value on the right hand side for a value on the left hand side, it should come in the result. For example, ID equals to 2 is not there on the right hand side. Still, ID equals to 2 has come in the result. The and rest of the fields have been left empty. Okay. So it's not like primary foreign key, it's just like standard joins. Okay, Girish? It's like standard joins. Yes, left outer is a keyword. So we could either say join A by ID, left outer, and B by ID. Or outer is optional. You could simply say join A by ID and left and B by ID. Okay, left and outer both are keywords. Okay, Damodaran? Alright, great. Now you could do the join, left join. Left join means even if there is no corresponding ID found on the right hand side, put the left hand side values in the output. Similarly, if you are joining A and B, okay, if you're joining A and B, and all right, Damodar, this is right join, and we say right outer or simply right, which means the right side, all the values from right side will be in the result, even if there is no corresponding value in the left. So we'll have one Sandeep, one Giri, and then we'll have three Saha. Okay, so this is called right join. And note the position of left and right, it is just before the comma. Okay, so Michael is saying that can you show in the terminal? I'll show you. So cat, let's say, what are we doing? So we have, okay, not people. Alright, I'll have to create a file. I'll have to create a file. See, this is what happens when you so we'll just try to create some data. We'll have to create data. Let me just see if I have already created. So let me just try to say cat A, okay, and same data, whatever we have talked so far. Let me just pick that up. Okay, not this. We're talking about this. Okay, so we have got cat A and cat B. Okay, let me just copy it to Hadoop. Fs copy from local into say data, and then inside that data we say, okay, we call it L instead of A, and we call the other one as right under B. Okay, now let's go into pig. In here, if you see, we'll go into the same folder, cd data, and we'll see L and R is there. You can see L and R, cat L, cat R. Alright, now if we join these, let's load this data. Okay, let's try to load this data. We'll say first load a lot like this, load L, and we are saying load R. So we can say we have got A and we have got B now, and now we can join A and B. Alright, like this we can say right outer equals to join A by ID and right outer B by ID. And when we say dump arrow, you will see the results. All right. Now let's see what happens. Okay. Now there's a question from Carl. Is there a way to preview a file in pig using head in the terminal? I think there is a tail command, but I'm not sure about head. You can try it out. Now you can see, Michael, you can see only the right hand side values, all of the right hand side value, 1 Giri, 3 Saha has come, while if it could match some value on the left hand side, it did match. If it could not find a corresponding ID on the left hand side, it has put the empty columns. Okay, makes sense to you, Michael? Now, Damodaran's question is why it took so much time to compute, and that is why it is called the batch-wise computation. And this kind of a time is actually normal when it comes to Hadoop processing. Great. All right. Okay, Carl, was I able to? So you can try cat or head if or tail from the inside pig, or in case you want to see few lines using Hadoop command, you can just use a command like, so it you should note that HDFS does not provide you head, although HDFS provide you tail command but not the head. Okay, for doing the head you could actually do Hadoop fs minus fs minus cat and then my file, and then you can put a pipe and say head. This is also equally efficient. So Carl, nothing to worry. So the way the things work is when head starts reading the data, and as soon as it finishes 10 records, it will send the signal back to Hadoop saying close the close the session. Okay, and then it wouldn't put any overhead on Hadoop system. All right, great, that worked. And that's exactly the reason why Hadoop guys have not provided a head command. They have provided tail command and no head command. So I was wondering, I just looked up, and their design decisions, it was taken that since whatever is done by the head can be done by Unix, therefore nothing to worry. All right. All right. So anybody can answer this one. What will happen in this case? So on left hand side we have one Sandeep, four Ryan, and on the right hand side we have four Giri and three Saha. And when we say right outer join, what will be the result? Correct. All right, we are doing right outer join. All of you keep that in mind. Yes, almost all of you. Some of you are correct. Some of you are correct. Yes. So the answer would be 4 Ryan, 4 Giri, and then empty 3 comma Saha. All right. Great. Great. Next is, in the similar way, we could do the full join. Full join as in, first it will list all the records which exist on left as well as right, and then it will do the left join, which is only the records which are found on the left hand side, not on the right hand side, and then only the records which are on the right hand side, not the left hand side. All right. So it will be Giri Ryan Saha. Perfect. So can anybody answer this question before we um, call it a day? If we joined two sets A and B, there were n1 records. If we joined A and B and it was a left join, there were n2 records in the results. If we joined A and B using right outer join, the total number of records were n3. So how many records will be there if we do a full join? Okay, anyone? So Anuj's question is, do we have Cartesian? So Cartesian product is not here in normal join. There is a separate command for that. Anuj is saying it will be n1 plus n2 minus n1 plus n3 minus n1. All right. Mm-hmm. Carl is saying n2 plus n3 minus n1. Awesome, awesome, great. Almost all of you got it right. It will be n2 plus n3 minus n1. Brilliant. All right. So that's pretty much for today. We will start from slide number 54 in the next session. All right. So if you have any questions, feel free to drop it. Drop your questions at Hadoop at No Big Data. Okay. All right. Okay, then everybody have a great week ahead. Thank you very much. Thank you, Savita. I am happy that you liked the session. All right. Thank you, Michael. I'm happy that you liked the session. Great. Bye bye. Have a great week ahead. Sure, Shrisha. I will send you the email. All right. Thank you very much. All right. So Arvind is saying I need to discuss on comparison. Comparison between what, Arvind? All right. Just yes, yes. So I think now we can do that. We can discuss it. You could just send me an email, or you just leave that question on the forum. I will try to answer that on the forum. And everybody, please be active on our forum. We will try to answer as much as questions on the forum itself. Okay. People are posting really good questions, such as interview questions and all. Those are very, very useful. Okay. So uh, ask your questions here. All right. Have a great week ahead. Bye bye.